In this question here, we also have a perimeter question with a little bit of a twist. We have 3 sides of a rectangular field, and it's going to be surrounded by 400 meters of fencing, the 4th side being left open, meaning it has no fence. So labeling this, I have a width, and a length, and I'm told that I have 400 meters of fencing. So that means I'm going to have a perimeter of width plus length plus width equaling to 400. So remember, your isolating equation is the one with the answer. So this is really 2 widths plus a length equals to 400, or subtracting 2w from both sides, I get that length is equal to 400 minus 2w. So let's go down to our substituting equation. Our substituting equation is going to be where we take this length and substitute it. So I'm trying to find dimensions to give me the maximum area. So your substituting equation always has to do with your max or min. So max area, well, maximum area is length times width, but I can only have one variable. I can't have 2 variables. So that means that max will be the length, which is 400 minus 2w, multiplied by the width. So let's distribute that in. That's going to be 400w minus 2w squared. Or rearranging that, I'm going to have negative 2w squared plus 400w. So this max equation is the one that I'm going to complete the square for. So over here, what I'm going to do is factor my leading coefficient, which is a negative 2. So negative 2w squared divided by negative 2 is w squared. 400w divided by negative 2 is negative 200w, and I'll leave myself some room. So go over to my grid here, and I take w squared. I take negative 200w, and I divide it into 2 equal pieces. And then I just factor my GCF. So in my first row, my GCF is w. In my first column, my GCF is w. W times w is w squared. Well, the only way I can get a negative 100w is if I multiply it by negative 100. Negative 100 times w, negative 100w. Same thing over here. This is also negative 100 because w times negative 100 is negative 100w. So to complete the square, all I have to do is take negative 100 and multiply it by negative 100 to get 10,000. So 10,000 will complete the square. So I'm going to add it and also subtract it inside my brackets. Now again, the reason I do that is because 10,000 take away 10,000 is 0, and you can add 0 to anything without changing its value. So let's look at this. I'll just move this over a little bit. Oops, there we go. Okay, so completing the square. So I know that my perfect square trinomial factors as w minus 100 times w minus 100, or w minus 100 squared. Now my perfect square came from this part here. I still have that negative 10,000, so I'm going to take my negative 2 multiplied by my negative 10,000 and bring it out. So negative 2 times negative 10,000 is positive 20,000. So let's state our vertex. Our vertex is opposite of the inside, same outside. And let's analyze. Your q coordinate or your y coordinate of your vertex is what the max or min is. Your 100 is when the max occurs. Now we're talking about an area, so that means that my maximum area is 20,000 meters squared. When it happens, well, we have all w's. That was our variable, was w. It happens when the width is 100 meters. So let's go up here and figure out what the length is. The length is 400 take away 2 times w. So the length is 400 take away 200, which is just 200. So I can come back down here and say that the length is 200 meters. So let me make that bigger and just check to make sure we answered our question. It says, find the dimensions that give the maximum area. So the dimensions are width 100, length 200. The maximum area is 2,000 meters squared.